Final exam review, part 4, statistics, for 18. Use the frequency polygon below to answer the questions. For A, how many families are represented in the frequency polygon? Well, the frequency polygon represents the number of children per family. The vertical scale tells us how many families. The horizontal scale tells us how many children. So, zero children were found in 8 families. 1 child each was found in 11 families. 2 children each were found in 18 families. 3 children, 11 families. And 6, 4, 2, 1, 2, and 1. So the heights of the points on the graph correspond to the number of families. So I just need to add the 8 plus 11 plus 18 plus 11 plus 6 plus 4 plus 2 plus 1 plus 2 plus 1. So I get a total of 64 families. To see how many children are represented in the frequency polygon. Okay, so 0 children were seen in 8 families. So that's 0 children. 1 child was in each of 11 families, so 11 children. 2 children were in each of 18 families, so another 36 children. 3 children were in each of 11 families, so another 33 children. 4 children were seen in each of 6 families, so another 24 children. 5 children were in each of 4 families, so another 20 children. 6 children were in 2 families, so that's 12 children. 7 children were in 1 family, so 7 children. 8 children were in 2 families, another 16 children, and 9 children were seen in just 1 family, so number 9 children. So it gives me a total of 168 children. For 19, determine the mean, median, mode, and mid-range for the set of data. So for the mean, that X bar stands for mean, we're going to take the sum of the data values, divide by the number of values. So if I add these values, 2 plus 7 plus 11 plus 26 and so on, I get 118, and there are 9 data items. So I get a mean of 13.1. Now for the median, we have to put the data in smallest to largest order. So that would be 227, 9, 11, 12, 15, 18, 26, 34. So I have 9 data items. If it's an odd number, there'll be one value that falls in the middle. So the median, you want the middle value, or if there's an even number of data items, the average of the middle 2 values. So here, the middle value, or the median, was 11. Now the mode is just the most frequently occurring value. You see that 2 occurs more frequently than any of the other values. So the mode is 2. For a mid-range, we'll take the lowest value, that's our 2, plus the highest value, it's 34, and divide by 2. So you get a range of 18. For 20, to get a B in math, Ronald Donald must average 80 on 5 tests. Scores on the first 4 tests were 84, 77, 83, and 75. What's the lowest score that he can get on the last test and still get a B? So let's let X equal score on the 5th test. So we know that the mean is the sum of all the values over the number of values. So to get a B, he has to get a mean of 80. And we get that by adding all the values. So that would be 84 plus 77 plus 83 plus 75 plus whatever he gets on that 5th test. So we'll add all the values and divide by the number of values. All right, so if I simplify this, I have 319 plus X over 5. Now let's get rid of this fraction. I'll multiply both sides by 5, or 5 over 1. So 400 equals 319 plus X. Now to get this X by itself, just subtract 319 from both sides. And you see that it needs 81 on that 5th test in order to have an average of 80. For 21, we want to determine quartile 1, quartile 2, quartile 3 for the following set of data. All right, well, the first step in finding the quartiles is to put the data in smallest to largest order. So I have 320, 350, 380, 390, 420, 450, 500, 510, let's see, 530, another 530, 550, 610, 660, 670, and 690. So I have 15 data items. The first thing I want to do is to find quartile 2, which is the same thing as the median. So remember, the median is the middle value of an ordered set of data, or the average of the middle two values. Since there's 15 data items, that's an odd number. There's going to be one value that falls in the middle. So there'll be 7 values below it and 7 values above it. So the median, the middle value is 510. Now, the first quartile is the median of the data items below Q2. So the values below Q2 would be those 7 values. So I want the median of those 7 values. There's an odd number of data items, so there'll be one value that falls in the middle, so it'd be 390. And Q3 would be the median of the data items above Q2. So there's 7 data items above Q2. That's an odd number. So there'll be one value that falls in the middle. It'll be 610. $22. We want to find the range and standard deviation of the set of data. Okay, so for the range, that's just the highest value minus the lowest value. So in this case, our highest value was 13, our lowest was 5, so our range is 8. Now to find the standard deviation, it's just the average difference between each of the data items and the mean. So we have to first find the mean. So to find the mean, we're going to add the values, divide by the total number of values. So if I add those values, I get 50. And if I count the values, there's 5 values. So I have a mean of 10. So to find our standard deviation, I'm going to list our data in a column going down, in a vertical column, under the heading of X. Now I want to find the average difference between each of these values and the mean. So our next step is to take each value and subtract the mean. So I'm going to take each of these values and I'm going to subtract 10 since it's the mean. So 10 minus 10 is 0. There's no difference between the value 10 and the mean of 10. So 10 minus 10 is 0. 5 minus 10 is -5. So 5 is 5 points below the mean. 13 is 3 points above the mean. 12 is 2 points above the mean. So if I add these differences now, I'm going to get a sum of 0 every single time. So to compensate for that, what statisticians do is square those differences. So 0 squared is 0. -5 squared. -5 times -5 is a positive 25. 3 squared is 9. 2 squared is 4. So while I couldn't find the average difference, I can find the average of the squared differences by taking a sum of those squared differences. We'll call this the variance. We'll take the sum of the squared differences and we'll divide by the total number of values minus 1. So it's 38 over 5 minus 1, or 38 over 4. So, should be 9.5. 38 divided by 4 is. So that's the variance. The standard deviation is the square root of this. So we don't want the average of the square difference. We want the average difference. So we'll unsquare it or take the square root of it. So the square root of 9.5 I have 3.082 or 3.08 to the nearest hundredth. I'm going to use the standard normal distribution table to determine the percent of data that for A is less than 0.66. So there's our normal curve. Now we make it standard by describing the data in terms of z-scores. So that 0.66, it's positive, so it'll be to the right of the mean. I want the area below this, or to the left of this. So to use my table, I'll use the table of positive z-scores. And under z, I'll look for 0.6, the whole number in the tenth. I'll find the hundreds. That's 6 hundredths across the top. So what I get is 0.7454. Now the area from the table measures the area from the z-scored to the left, always. The table area measures the area to the left of the z-score. Okay, now what we're interested in is the percent of data. So I'm just going to multiply it by 100, tack on a percent sign. So 74.54% of the data will be less than the z-score of 0.66. All right, now to find the standard, to find the area from that standard normal distribution table greater than a negative 1.40. So z0 is here. A negative 1.40 would be here. We want the area greater than that or to the right. So I'll use my table. Now I need the table that has negative z-scores in it. So the whole number in a tenth under z, negative 1.4. Now for the hundreds, I have to find that across the top. Well, it's 0 hundredths. So I have 0.0808. But here's the thing. The area from the table measures only the area to the left of the z-score we looked up. So to find that area to the right, we have to subtract it from 1. So it's 1, I can add as many zeros as I want, minus that 0.0808. You get 0.9192. And the question asked us for the percent of data, so I'll multiply by 100 and tack on a percent sign. So 91.92%. Now to find the area from the table between a negative 1.12 and a positive 0.56. Okay, so 0 is in the middle. Negative just goes to the left of it. 0.56 is positive, goes to the right. I want the area between these two. So I'll look them up. On the table of negative z-scores, under z, I'll do the whole number in the tenths, negative 1.1. That 200ths I'll have to find across the top. From the table, I get 0.1314. Now, the area from the table measures the area just to the left of the z-score we just looked up. Now, if I look up that 0.56 on the positive side, under z, the whole number in the tenths, so 0.5. Now, 600ths, I'll find that across the top. And I get 0.7123. So that measures the area from the z-score we looked up to the left. Well, I don't want either one of those areas. So to find the shaded area, the area between, I'll take the larger area, 0.7123, subtract the smaller one, and I'll get 0.5809. But this question asked us to give the answer as a percent. So 58.09%. Okay, 24. The length of human pregnancies from conception to birth approximates a normal distribution with a mean of 266 days and a standard deviation of 16 days. What percentage of all pregnancies will last between 240 and 270 days? Okay, so I'll draw my curve. The mean goes in the middle. It's 266. And I'm interested in pregnancies between 240, it's less than the mean, so it goes to the left, and 270. So I'm looking for the area between those. So these numbers represent days. Our next step is to convert these days to z-scores. Using the formula, the value minus the mean over the standard deviation. So if the value is 240, the z-score is 240 minus the mean of 266 over standard deviation. We said the standard deviation was 16. Now we run around all z-scores to two decimal places. So I have a negative 1.63. I know the mean has a z-score of 0, so now I'll do for the value, find the z-score for the value of 270. So using the formula, it's the value always comes first, minus the mean, over a standard deviation of 16. So I have 0.25. Now, next I have to find the areas to the left of these z-scores. So that negative 1.63 on the net table of negative z-scores, I'll go down to negative 1.6. And across the top, I'll find 300ths. They have an area of 0.0516. Now that measures the area from the z-score to the left. All right, so now if I look up z-score of 0.25, use the positive z-scores. So 0.2 under z, the whole number in the tenths, that 500ths, I'll find that across the top, the 0.05. So when I look that up, I get 0.5987. Now, the area I get from the table measures the area to the left of the z-score. Well, I don't want either one of those areas. I want the area between, so I'll take the larger area, that 0.5987, and subtract the smaller one, 0.0516. And I get 0.5469. Now the question said what percentage, so I need to convert that to a percent. So I'll multiply it by 100, which moves the decimal point 2 places to the right, and tack on a percent sign. So 54.69%. 25. The Edwards Theater chain has studied its movie customers to determine how much money they spend on concessions. The study revealed that the spending distribution is approximately normally distributed, with a mean of $4.11 and a standard deviation of $1.37. On Saturday, 2,000 customers visited Edwards Theater. How many of these customers spent less than $3 on concessions? So we have to first find what percentage of customers spent less than $3 on concessions. So to do that, since we know that the distribution of spending is normally distributed, I can use that bell-shaped curve, and I'll put the mean in the middle. We said the mean was $4.11. Now, the standard deviation was $1.37. We're interested in the percentage of customers to spend less than $3. So $3 is over here somewhere. So less than that to the left. So these are the dollars. I need to convert these values to z-scores. Well, I know the mean has a z-score of 0. For $3, use the formula, the value minus the mean divided by the standard deviation. So the value is $3. The value always comes first. It's $4.11 over the standard deviation of $1.37. So when I get my z-score, I want to round it to 2 decimal places. 1.11. So what I need to do next is to convert that z-score to an area. So I'll use my table. So the negative z-score, so the table that has the negative z-scores on it. And under z, I want the whole number in the tenths, so negative 1.1. Across the top, I need that 100th. So I have 0.1335. So the area from the table always measures the area to the left of the z-score we looked up. So right here. So if we wanted to write that as a percentage, then we could say 13.35% of customers spent less than $3 on concessions. It's not exactly what we wanted to know. We wanted to know how many. So on Saturday, 2,000 customers visited Edwards Theater. So 13.35% of the 2,000 customers will have spent less than $3 on concessions. So putting that 13.35% back in decimal form, of means times, I get 267 of the 2,000 customers spent less than $3 on concessions.